In question C, we're asked to find the distance travelled by the train in each of the following sections. So the distance travelled on a speed time graph is found by getting the area under the graph. Rather than flicking back up to the graph, I'm just going to sketch what I think each section looks like. So the first 60 seconds involves a diagonal line that goes from 0 to 60 on the time axis. On the speed axis goes from 0 up to 20 meters per second. So to find the area under the graph, that's this area in here. This is the area of a triangle. So we can say the distance is equal to half times the base times the height, because it's a triangle. So that's a half times 60 times 20. Probably the easiest thing to do is to say that's the same as 10 times 60, because half of 20 is 60. So that gives us a distance of 600 meters. From 60 to 180, so again, if I was just to sketch it, I'm not going to go from start. So now I'm going to say my 60 is here and my 180 is here. In this section of the graph, I just get a flat horizontal line at 20 at all points. So again, the distance is the area in here. Let's mark that in. That is just the one side multiplied by the other. So the height is 20 and the width of it is 120. So that should be 2,400 meters. Next section, from 180 to 240 seconds. Again, let's do a little sketch. It goes from 20 up to 25 as the time goes from 180 up to 240 on this axis. So this time we want the area of a trapezium. So the way I remember the area of the trapezium is to say I'm going to do the base times the average height. So the shaded area, or the distance, should be equal to base width times the average height. So in this particular case, the base is again 60, and the average height, well, we can probably see it's 22.5, but if we say 20 plus 25 over 2, that's how we get the average height. That gives us a distance of 1350 meters. Next one, from 240 to 360 seconds. So at all points here, the speed was at 25 meters per second. The time goes from 240 up to 360. So we're again just finding the area of this rectangle. So the distance should just be equal to the height, which is 25, multiplied by the base, which is 120. It's 3,000 meters. From 360 to 600 seconds, so the final part of our graph, from 360 to 600 goes from a speed of 25 down to a speed of 0. Should be a straight line. Doesn't look very straight, does it? It'll do. Again, we've got a triangle, so the distance is equal to half times the base times the height. That is a half times the base here is 240 seconds and the height is 25, giving us another 3,000 meters. Then the final part says the total distance for the whole journey. Well, for this, then we're just going to add up all those distances that we've just had. So if I write it out as a sum from the top, I've got 600 plus 2,400 plus 1350, let's underline them as I go so I don't miss any. 1350 plus 3000 plus the last 3000 down here at the bottom. I think we can do this in our head. These first two add up to 3000, so when I put those two together, that's 9000. So putting this one on top gives us 10,350 meters, or we might write it as 10.35 kilometers.